Welcome to another Vectra AI podcast. Today we have Campbell Robertson from our product management team to talk about how we are strengthening our offensive security solutions with advanced C2. So thank you, Campbell, again for joining us.
Yes, thank you.
Perfect. So let's jump right into it. So first, do you mind giving us some background on what command and control, otherwise known as C2, is?
Yeah, so if you're not familiar, command and control is a technique where an attacker would deploy malicious software to a host machine or a client, which will then establish a connection to an external server. And then that external server is maintained by the attacker and sends commands to the infected client that the client will then execute and then upload back to the server. So for example, say we have a client and a server connect, and the server tells the client to exfiltrate data. The client will do that and then unknowingly send it back to an infected server, to a malicious actor who might hold that data for ransom or just sell it to other bad actors, and then all that data is exposed. So we understand the severity of this attack, and then it's also alarming to note that nearly 70% of breaches involve some form of C2. So because of the seriousness and just how abundant it is in real life, Vectra understands that C2 is a essential part of our coverage for our customers. So we need to have an accurate, diverse, and clear coverage for C2. Not only because of these facts, but because traditional security systems don't have that novel C2 signal that Vectra has, and so we really provide that next step of coverage, so we don't let anything fall through the cracks for our customers.
Perfect. Thank you.
Mhm.
And with that, we want to kind of just talk about the problem that we are trying to solve. I know you just spoke to this a little bit, but if you want to elaborate more on that.
Yeah. So the problem that we have is we know that we need this amazing C2 coverage, but that's a lot easier said than done. It's hard to train C2 algorithms or get C2 examples. Algorithms take a great deal of high quality data to properly train. And then given the amount of protocols, configurations, parameters that these C2 tunnels and breaches can take on, there's an endless amount of samples that could be created. And with these samples, they can be created by hand, but like I said, there's just so much data that is needed and that could be changed, that it's just not feasible to solve this on a human scale alone. And so Vectra looked around and tried to find a tool that would cover all of the behaviors, protocols, and configuration that Vectra needs to have coverage for. But we quickly discovered that that tool does not exist yet. And so Vectra partnered with Michigan State University's Capstone Department to build this tool out. So over the course of 3 semesters, computer science seniors built out what we call the C2 simulator. I was lucky enough to be one of the people on Team Vectra around this time last year. So that's why I have the background on the C2 simulator. So the simulator allows Vectra to stay ahead of the training models and keep the data up to date, and includes new behaviors that the field has not seen yet or that other tools don't even cover for yet. So overall, we're expanding and validating Vectra's C2 coverage with this tool.
Perfect. So I think it's really important to call out that we basically took a very manual and complex process for getting these C2 detections, and we made it a lot more scalable by applying our AI as well as our expertise in cybersecurity and C2 coverage. So very good point there.
Yeah.
So let's jump to the next slide here. So this is just illustrating a traditional command and control. Do you want to explain this further?
Yeah, so like I said in that opening slide, the server and the client will connect, and then the server is sending those evil commands over to the client that the client will then execute and then upload back to the server. I think it's helpful to see a visual diagram before we go on to the C2 simulator examples.
Perfect.
Mhm.
Okay. So with that, we have one of those C2 examples if you want to explain this a little bit.
Yeah. So the C2 simulator will create and generate a PCAP after each simulation um, that you can look at in Wireshark and do any in-depth analysis with. And then that PCAP that's generated will also be what is eventually sent to our training models. But here we have just a UI screenshot of the simulator that has a lower level information that what you can see in Wireshark, but it's good enough. So just a quick overview of this UI. In that top row, we have some parameters that the C2 simulator takes in. So notably, I'll call out that we have about 6 protocols that the simulator can represent. We can do multiple tunnels. This is just a one tunnel simulation. And then we can do a short or a long connection type. And then, of course, any second with your beacon and jitter amounts. So this is a 2-second beacon type or beacon time. And then to the right, we have the playbook, which is what we call the list of jobs that the server is going to send over to the client. So here we have a port scan job and an Active Directory scanning job. We can also do any arbitrary command, upload, download file, exfiltrate data, like I said in that opening slide again. So we have a lot of opportunities to simulate actual data being sent back and forth, which is actually what we see in the middle of this screenshot, the PCAP data. So this is just your classic network traffic graph with the client traffic and server traffic represented. So for this simulation, we can see, like I said, we have a 2-second beacon, which makes up the majority of those peaks that we see. And they do fall on the 2-second intervals, which makes sense. That's what we would expect for a 2-second beacon time. And then the jobs we can see are executed between those 2-second intervals, since they are both being executed at an uneven time mark. So the first job is executed, that's a port scan, and the port scan data makes up for a larger amount of data than what the server is being sent. So that's why we see that spike in green traffic. So that represents the client traffic. And then the other port or playbook command is the Active Directory scanning job, which is not any more amount of data than a beacon. So we don't see any spikes there, but that is what we would expect and normal to see there. So that's our traditional C2 example.
Awesome. So we will move on to our beaconless example.
Mm-hmm. So this simulation is the same as our beaconing example. The only thing that is different is the beacon time. So here we have a 0-second beacon time, which means that our server and client will connect and the server will send commands without the client having to beacon to the server to receive those commands. So here, as in comparison to that first graph, we see a lot less spikes or peaks in the data, which accounts for those beacons not taking place for this simulation. So again, that's what we would expect. And here we see just a couple peaks for the client and server to connect and then disconnect at the end. And then in the middle, those two peaks are our commands being executed. So the port scan and the Active Directory scan happening in the middle.
Great, thank you. We will move on. Can you speak to, some more background on a REST API attack that we have here?
Yeah. So while the command and control from the server to the client is the most popular type of or form of C2, Vectra also wanted to focus and build out new and emerging attacks using this tool. So that is what the REST API attack is. It's a form of a hybrid attack that utilizes a REST API endpoint as a go-between the server and client. So here the client or the server will send commands through the REST API, and then the client will upload responses through the REST API before it gets to the server. So that is a little overview. Again, I think it helps with the diagram to
Yes,
visualize it.
definitely. Thank you. We will move on. And do you want to talk about our REST API attack in the actual simulation tool here?
Yeah. Yeah. So it doesn't, without knowing what these simulations are, what the protocols are, you can't tell anything by just the PCAP data. It's not that interesting to look at. I acknowledge that. But this is a REST API attack with a 2-second beacon time, which again makes sense why we see the increase in peaks like we had in that first example. And then we have some commands that have a lot larger data that we've seen in the previous examples. So the upload and download file both take on a large amount of data in the client, which are those first two back-to-back big spikes that we see in client traffic. And then the port scan again takes that large amount of data which is the next large spike in client traffic after that. So that's a brief overview of what we see here.
Awesome. Thank you. And with that, we will move out to our conclusion for this podcast.
Yeah, so to wrap it all together, Vectra is constantly innovating to improve our coverage for our customers and to stay ahead of attackers, which in turn, of course, benefits our customers. And then not only is the project benefiting our customers, I mean, that's the main end goal, but it also benefits the students who have worked on this project with MSU. Speaking from experience, it was a great semester. And then we also walked away with a first place award 3 semesters in a row. So that is great for students to have. And then while Vectra takes a break from sponsoring the college projects. This year, a couple weeks ago, we announced the AI scholarship program, which is a scholarship opportunity to foster the next generation of AI engineers in cybersecurity.
Perfect. Thank you. Yeah, I think it's really important to call out that we are always fostering innovation both here at Vectra and within the talent pool of the next engineers, data science, et cetera, that are helping to combat these types of attacks. So thank you for calling that out.
Mhm.
And with that, we will close up this podcast. Thank you all for listening. Feel free to subscribe to our YouTube channel, Spotify, anywhere you listen to podcasts, and also comment, like, ask questions on there. We love to see the engagement. And again, thank you, Campbell, for your time today.
Thanks, Nicole.